Hello students, so please welcome back in our channel. So before starting our today's session, in the last session we have just completed the formulas based on hyperbolic and the circular functions, and hope you all understood these all the formulas and you have written in your lecture notes. Now let's start with the same part 1 of the complex number, and here I am going to start examples based on our last session. Here it's given a first example based on the all the formulas and the results, and the question is given: prove that sin h inverse x equals to log of x plus under root x squared plus 1. Okay guys, now as we have discussed that the last slide of our previous sessions, again repeating guys, the last slides of our previous session, and at the last the formulas, whatever the formulas are given, okay, so these all are the results we are going to prove right now. So from this all the formulas, I'm first starting with the sin h inverse x. Okay, so here I'm going to take a supposition that taking y equals to sin h inverse x. Okay, and then after I'm just making a subject of x, so that it will be sin hy, right? यहाँ पे मैंने x का subject बनाया. It means from here I'm removing inverse function. So of course we can write the values of x. So that will be sin hy. यानी कि अब applying sin on both the sides, we can see that also. That applying sin on both the sides, you can get sin hy equals to x. Okay. Now you know the hyperbolic function of sin hy as we did in our previous session in the formulas. So that will be e raised to y minus e raised to minus y upon 2 equals to x. Now applying this, I'm just doing the cross multiplication, so that it will be e raised to y minus e raised to minus y equals to 2x. And e raised to minus y, I'm just doing one more simplification, so that we can get e raised to y minus 1 upon e raised to y. Okay. Now writing this all the terms in a single side, so in all the terms I have written into LHS. So these equations we can call as the quadratic equation. Okay, so this one will be your quadratic equation, as here it's given e square yani ki e raised to 2y. Okay, so this equation is said to be a quadratic equation. Quadratic equation yani ki we can say that in Gujarati, I think, Purnavak Padavali. Okay, so this one is a quadratic equation, and from this quadratic equation we can find its roots also, and that will be in the terms of minus b plus or minus under root b square minus 4ac upon 2a. Hope you all aware of this formula, and so I have just found out its roots, and so that's why it is this one we are getting x plus or minus under root x square plus 1. And I'm removing exponential function, so we can find the values of y, and that will be of course here, from here the exponential will be removed and it will be converted into the log form, logarithmic form. So the y will be log of x plus or minus under root x square plus 1. Okay, so now here you can see that a log of x plus under root x square plus 1, and the another will be x minus under root x square plus 1. So as you know all, one term will be positive and one will be the negative. So as you know all, if you will put here the negative sense, yani ki log of x minus under root x square plus 1, then it can't be possible negative terms, because here it's written a log function. I'm highlighting guys, here it's given a log function, and the values of logarithmic will not be negative anytime. Okay, so of course this negative sign will be removed, the function of with negative signs it will be removed, and the final it will be the y equals to log of under root x, log of x plus under root x square plus 1. And in place of the y we can write its value, and that will be sin h inverse x. Okay, because as I have supposed here in the beginning of the example. So it will be sin h inverse x equals to log of x plus under root x squared plus 1. Second example, it's the same like for the sin h inverse x. So I'm not going that example you have to do in the assignments. And third one we are going to start, and the question is given, prove that tan h inverse x equals to 1 half into the log 1 plus x upon 1 minus x. Okay, so the beginning will be same for all the examples. So let y equals to tan, taking a supposition, y equals to tan h inverse x. So and then applying tan on both the sides, so that you can get x equals to tan h y. Now then you can write the values of tan h y, yani ki the hyperbolic function for the tan. So hope you all know guys, because this one we have studied in our previous session. So that will be e raised to y minus e raised to minus y upon e raised to y plus e raised to minus y. Okay, now see the into the equation guys. Here it's given 1 plus x upon 1 minus x, yani ki log of 1 plus x upon 1 minus x. Now here you need 1 plus and 1 minus, it means it is same like componendo and dividendo, yani ki in the other language we can say it will be yog vyog, by taking yog vyog. Okay, so by applying, by using componendo and dividendo, you can take this dividend and componendo, like 1 plus x upon 1 minus x. So here only in this equation, 1 minute guys, I am also circling out this one equation. So in this equation we are finding value 1 plus x upon 1 minus x form. So 1 plus this and 1 minus this. Okay, so by using this formula, I mean 1 plus x, by applying this componendo and dividendo, you can find this one function, and applying this, converting it into the numerator, you will get this one e raised to 2y. And then after uh, removing this exponential function, so that you can get 2y equals to log of 1 plus x upon 1 minus x. And as you can check your equation, it's given into the form of y, and y yani ki tan h inverse x. Okay, so just making a subject of y, you will get 1 half log 1 plus x upon 1 minus x. And in place of in the last you will put the value of y, so that you will get tan h inverse x equals to 1 half log 1 plus x upon 1 minus x. So hope you all understood this one very in the easiest language guys. And now it's given a fourth example, and the function is given, prove that cot h inverse x equals to 1 half log x plus 1 upon x minus 1. So again this one will be the same as per the third example. So this examples again you have to do with your own self, and here you have to apply again componendo and dividendo, but in the format of x plus 1 and x minus 1. As you can see that here it's given x plus 1 and x minus 1. Okay guys, so it's not given 1 plus or 1 minus x. So at that the procedure, little bit procedure will be changed, and rest of the method will be same only. So here also I have given its simplification also, and you can see that if anybody was not able to do. And here it's given, here it's the completion of the fourth example. And now more examples we will do in our next sessions. Till that please do this all the practice. Thank you guys, see you soon.